Okay. Well, hello everyone. I'm going to be moderating today's session. I'm Virginia Morejon. I'm one of the new young ambassadors of the EMB ECOP network, and I'm also a PhD student in Ireland and supported by the Irish Marine Institute. So, just before we get started, I would like to go over some housekeeping rules. First, we're going to have the presentation, but we'll have time for questions at the end. So just make sure that your name is clearly entered and that your microphone is muted unless you're speaking, but also raise your hand if you would like to say something, or you can also use the chat function if you would like to leave any comments or ask any questions. And very importantly, please be respectful and use appropriate language. And just a few words on the ECOP network. So the network has been established by previous EMB Young Ambassadors and the Secretariat. On more recent news, as of October 24, the network has been officially formalized as part of the EMB. And this with the goal of the EMB to continue to support ECOPs, to provide them with more exposure to the linking of the science and marine policy making, but also to increase their networking opportunities in meeting peers across Europe and also gaining a voice at the EMB level. So I'm very excited to present our speaker today, Nikia Gooding. So she's a remote sensing research officer at the Institute of Marine Affairs in Trinidad and Tobago. So Nikia and we recently met at the All Atlantic Ocean Research and Innovation Forum that took place in Canada about a month ago. And we were there as ECOPs and working together with other senior scientists. And at the end of it, we had to present our ideas in front of a big audience and that included policymakers. So it was quite interesting, but we're very happy to have her here today and to share insights on the work that she's been doing in relation to Earth observations for ocean observations in Trinidad and Tobago, and how that is being used to inform decision and policy making in the wider Caribbean region. So without further ado, I'm going to stop sharing my screen now. And so Nikia, the floor is yours whenever you're ready.
Thank you, Virginia. So while I share my screen, I'm just going to express some thanks. I really appreciate being invited to speak to you all. It's quite an honor, um, even just to speak in terms of like some of the work that we do in Trinidad and Tobago and in the region, but also to have some sort of follow-up post-meeting Virginia to be able to do something, after that connection. And then to spread the word a bit more about EO. So as Virginia said, my background is in remote sensing. I am a GIS professional, and I very often hop on the soapbox of increasing Caribbean representation and participation in circles where we are not very included, especially towards leveraging technologies like Earth observations for solutions and for policy decision making as well. So, I will be talking a bit about some of the work that we do at the Institute of Marine Affairs. So I am located in Trinidad and Tobago, which is towards the south of the Caribbean. And because of that, we are in pretty unique juxtaposition location-wise, just oceanographically, but also geographically. Yeah, so before I get into it, I'm just going to give a brief overview of what EO for ocean observations even is. So EO is Earth observations, and it is specifically related to the use of GIS, the use of satellite technology, remote sensing, and in situ collection as well for ocean observations. And we can all, I think, understand the importance of ocean observations, but also how everything we do on land affects ocean observations. So just, really using that ridge to reef concept and understanding that every action on land impacts the health of our oceans. And so, being able to leverage Earth intelligence is particularly important for terrestrial and marine and coastal activities. And this is just a simple pipeline about the ocean observations value chain. And it's really just about recognizing, for example, that maps tell very important stories and they can also be particularly impactful. And you really use as a tool for science communication, reading a document or reading an Excel sheet with, thousands of data entry points can be very hard to digest. But when you look at a map and it's kind of a visual representation of the same data, it's usually very easy to articulate the salient points. And it's also an easy way to communicate socioeconomic benefits as well, which sometimes might fail with, words on a page. So a little bit about the geomatics unit. So the Institute of Marine Affairs conducts coastal and marine environmental research, and we inform decision makers, and we also assist in policy formulation and implementation. So one of the most recent success stories has been the passing of the ICZM framework, so the Integrated Coastal Zone Management Policy Framework, that the IMA is now very much involved in through the National Committee to bring about action towards the sustainable management of our coastal zone. And through that, it also kind of frames some of the scope of works at the Institute and, through the geomatics unit as well, which is where I'm based. So we have research programs which are ongoing. They don't necessarily stop. And this includes some of what we're going to talk about today. So the spatial mapping of living and non-living coastal resources of Trinidad and Tobago, as well as the marine pollution surveillance program. And some of the research projects that we have going on in the unit currently includes the marine space remote sensing and trajectory modeling project, as well as the above ground and below ground carbon assessment for mangrove forests and the hydrological study of the Caroni River Basin. So I will be touching on a few of these as we have our discussion this morning. Well, this morning for me, afternoon for some of you. Some of the future activities. So some of these have actually already started, as in within the past couple of weeks, and then some of them will be starting more as the year kind of turns over to 2025. So these include the regional expansion of oil spill monitoring area, validation of our oil satellite tracking, well, further validation, the marine spatial plan development for the Gulf of Paria, which is actually this zone here for Trinidad and Tobago, under the Marin project, which is mostly based around Tobago, some benthic habitat mapping, Sargassum forecasting, which will be for our entire exclusive economic zone, which is on screen, a pilot project through the Global Coast, which is further managed by Ocean Predict under Goose, an updated coastline change detection for our entire two islands, a mangrove blue carbon assessment, which I will talk about again a little later, through the GCF, as well as this component of the marine space remote sensing project will be launched maybe later next year within the fourth quarter. And that is specifically looking at ocean health monitoring through a water quality product with applications towards a multi-index criteria for coral reef stress, specifically looking at ocean warming and acidification, as well as harmful algal blooms and eutrophication. So first, we're going to talk about one of the most important programs at the IMA in the geomatics unit, which is the mapping of living and non-living coastal resources. So this program also controls our spatial data management. So the IMA has a marine data hub, which is basically like the front end to our spatial database. And I will share shortly how you can access the Marine Data Hub, but it is a really good resource for the public the data sets that we can share publicly, that we either collect, we're custodians for, or we manage and update regularly. And some of these data sets includes data towards wetlands, so wetlands extent and distribution, whether it's seagrasses or mangroves, benthic habitats, shorelines and coastal zone information, climate change impacts, ocean health and marine pollution as it relates to marine chemistry as well. So this is how you can access the MDH. You can visit our website, sorry, and it is linked on the website. Or you can get into your browser and type in mdh.ima.gov.tt, or even just by scanning the QR code. So the MDH was developed through a funding project through the Global Biodiversity Information Facility, which is funded by the European Union. And it is a platform that we are really trying to sustainably manage towards sharing data. So we really believe in the fair and care principles of open knowledge and open data practices, and we are, actively living that. So in Trinidad and Tobago, we have a variety of seagrass beds. And so on screen is mostly a seagrass bed as it relates to the Thalassia taxonomy family of seagrasses, or also called turtle grass. And we undertook a recent updating of our seagrass maps. So we would have mapped it in the past based on different satellite images and aerial images that was accessible and freely available, either through national acquisition programs or through projects, or even through Google Earth imagery. And what we did when we mapped our most recent data set, so that would have been finalized last year, but it would have been based on imagery from April 2022, was that we also took it a step further and we mapped based on density of the seagrass patches. So we would have done a number of different data collection exercises, which includes mapping from satellite imagery, as well as just distributing some ground truthing points and going out to this area, which is Southwest Tobago. And yeah, actually taking a look, either like jumping off of the boat and doing a bit of a dive, or looking off the bow of the boat if the water was shallow enough to ascertain whether or not it really was seagrass, or if it was algae or even coral rubble, because all of these substrates exist in this area. So this is also one of the protected areas in Trinidad and Tobago. It's called the Buku Marine Protected Area. And this marine park is an area where we have seen significant change in seagrass extents um, over the last 30 years. So on the right is the right lower bottom of your screen is really just that map where we did the initial mapping with these ground truth points, and then your top left, it would have been a finalized map. What we also did was we took a side scan sonar and ran lines. So in February of 2022, I was on a flat bottom boat. We just went back and forth throughout the Bonacord Lagoon and Buku Marine Park area, as well as Pigeon Point in Tobago. It would have been a very scenic field trip, but it was also very, very long. It took I think about 8 or 7 days for us to do a cross hatch of lines within the lagoon, as well as to do the lines in the Nylon Pool and Buku West area, as well as Pigeon Point. We would have also been able to gather through this activity, not just mapping of the seabed for bathymetry, but also imagery for the seabed itself. And those side scan lines really help to inform as well the ground truthing points that we use to validate the satellite tracking, the satellite mapping. And this is just one of the final products from the bathymetric data that was collected from the side scan sonar. So next we're moving on to mangroves. So the IMA did produce a book on mangrove forests in Trinidad and Tobago. And this was funded by Point Lisa's Nitrogen Limited, which is a locally based company that works very near to one of the mangrove forests in Trinidad and Tobago. And through that book, we would have updated our mangrove extents. So previously, we would have had 1994, 2007, 2014 mapped, but through that book, we would have undertaken an endeavor to update our change detection to 2018 to 2020, ahead of the book publication, which was in 2021. And here I'm really just showing how much mangrove changes. So in Southwest Tobago, which is, we would have done the seagrass in this same area, we also had some really old aerial images. And you can see from 1956 to 20, sorry, from 1956 to 2021, just how much the mangrove forest has um, proliferated into the Buko area, but also how much fragmentation occurred. And really, just as the area got more developed and we had a little bit of expansion into urban areas, it came sometimes at the loss of mangroves, either through direct losses or through changes in hydrology and drainage. And so, one of the things that we really use this kind of information for is to help inform rehabilitation and restoration activities. Just because you're seeing a dieback area or loss of extent, it doesn't always mean the solution is to go and plant more mangroves. In a lot of the instances, it requires further investigations into the hydrology of the area. So is the mangroves really being flushed on a regular basis? Understanding the topography of the area. And those things really help to inform what is the best restoration action. So very often we would share this information with our wetlands ecologists at the Institute. And help to make recommendations towards restoration activity. And something that I'm going to talk about a little later as to why we need to even restore or conserve our mangroves is because of the great ecosystem service that it offers as a carbon sink and store. But in the meantime, we're going to get into oil spill detection and monitoring in Trinidad and Tobago. So the Marine Pollution Surveillance Program started in 2021, and it was an endeavor that came about through a regional meeting with Ayokaribe, UNEP SEP, so the Caribbean chapter of UNEP, as well as NOAA Nestis, where it was kind of recognized among Caribbean countries and Latin American countries that there was a need to build the capacity for oil spill monitoring in our region so that we can then operationalize and perform this activity for ourselves to protect our waters. And so that meeting took place around, I want to say, the end of 2020. And in 2021, the Satellite Analysis Branch under NOAA Nestis approached the IMA and asked if we would be interested in receiving this training and in starting a national program. And we would have then included some other stakeholders from our country, so the Environmental Management Authority, as well as the Ministry of Energy and Energy Industries, as they both have very, very important roles. They are the action agencies for our National Oil Spill Contingency Plan, and so we would have included them in the training. And thereafter receiving the training in 2021, we would have started a national program. And this program has been ongoing every day ever since. And it would have also led towards the starting of a regional program, which is COSTA, the Collaboration for Oil Satellite Tracking in the Americas. And it really is an international effort now to build capacity for the region. The initial training was developed and coordinated by the Satellite Analysis Branch out of NOAA. But since then, a number of countries have received training after Trinidad and Tobago, including Mexico, Peru, and Colombia. Peru specifically has a very successful national monitoring program. The Mexico program doesn't necessarily sit within their government, so SIGOM is not governmental, however, it is recognized as one of the partners of Costa. And Colombia right now is actually trying to reorganize how the program should really materialize. So they did have a national monitoring program that started. However, just recognizing sometimes how you can have personnel and resource constraints, it's now being reevaluated. Jamaica is supposed to start training next. However, we've also had interest from Sika through Cocotram, so in Central America, as well as Guyana. So currently, the green areas are areas that are being monitored, and the orange areas are areas that have received interest and have also expressed that they may be able to cover these exclusive economic zones once they've been operationalized. And currently, the yellow is what IME is seeking to expand towards. And this is really supported by RAC Rempatec, which is the Regional Activity Center for Oil Spills under UNEP-CEP and enacted by the Cartagena Convention, but it's very much supported by these entities, specifically Geo Blue Planet and AmeriGeo, which is the America's chapter of the group of Earth observations. So as mentioned, we really are trying to see if we can expand the monitoring area through a collaborative effort with RAC Rempatec. They've been offering a lot of the coordination, so they would have reached out to all of these countries listed last year to find out if they're interested. And since then, we have expanded, so we don't only just do our national waters, but we have expanded to Grenada, and we will be expanding to St. Vincent and the Grenadines. I actually have a meeting on Thursday with Noah Nestus, SAB branch, and Rick Rampatech for us to get the go-ahead to go ahead and expand to St. Vincent and the Grenadines, as well as to reach out to some other countries within the wider Caribbean region that also have GIS and remote sensing capacities and may be interested in receiving training and becoming a partner. So Costa has supported a number of notable oil spill events. Right after we got trained, actually, there was a major oil spill in our Gulf of Paria in the Guayakara area. So we got some what we would call baptism by fire. So right after we received the training, we had this massive oil spill that carried on for a number of days that we would have assisted in tracking, as well as the 2022 sunken tanker. So unfortunately, this was a sunken tanker that resulted in a fatality and a number of serious injuries. This would have been in June of 2022. And it was off of the northwest area of Aruba. This is an example of some of the reports that have been issued for these major events, as well as, some of the crews that were rescued from the sunken tanker. And most recently, the Tobago oil spill, which unfortunately was in our waters, in our national waters. And this would have first been reported on the morning of February 7th this year, and it would have continued spilling for a number of months. So Earth observations and satellite tracking directly informs the response and the management of oil spills, not just for its location tracking along the ocean surface and seeing how it travels along the ocean surface, but very specifically, to inform the response managers how to allocate resources, whether it's the deployment of a boom, whether it is cleanup efforts if the oil should wash ashore, which did happen in our case, within the first few days, or just, coordination of transboundary spills. Oil does not have eyes, it's not able to recognize geopolitical issues and decide, okay, maybe I should not leave these waters. It will travel where the currents take it. And so, it's very important to have that kind of eye on the sea and understand where the oil is going to go next, even. And that's where trajectory models become particularly important, as informed by Earth observations, but also as it then informs further action and management for response. So these are examples of one of the first few oil spill reports that was issued. So it was first reported on the 7th, and this was a report that was issued on the 9th, but from the imagery on the 7th. The vessel was located right here, which is south of Cove Tobago. The green areas are mangroves. So you can see there are some ecologically sensitive areas. The vessel was also lodged on a coral reef, and it was particularly close to some of the long-term coral reefs that we monitor at the Institute for Ecological Health, which is Flying Reef. And they really would have just had these very significant oil plumes on the ocean surface. One of the other ways that we are using EO to monitor marine pollution and specifically oil in our waters is through a combined SAR tower system. So this is one of the in situ data collection opportunities. It is a joint project with the Ministry of Energy and Energy Industries, the IMA, and our Coast Guard, where they are deploying two towers, one in Point Good, which is in Chaguaramas, and then one on top of Hyatt Tower, which is in Port of Spain, our capital. And this is giving us another form of validation. We got a significant amount of validation through the Tobago oil spill, as the Tobago Emergency Management Authority would have had drone surveys and aerial surveys that our air guard also assisted with, and that really would have helped to validate some of the satellite tracking that we were doing. And this is just another method once it's fully operational, because right now there's only one of the towers that is connected to the system, but it will be semi-automatic. So we'll kind of just ping off, say, hey, we found something strange, come and take a look. And one of the analysts here at the IMA will then check it out. And through analysis of the imagery, the radar imagery, be able to either issue a report or confirm a false positive, which is also particularly important for the long-term data management. The other form of validation that we are seeking to do, and we're just waiting for the Coast Guard to assist with the deployment, is to coordinate with when we're usually getting satellite imagery. So we use only open source imagery, so mostly Sentinel-1 and 2 from the ESA Copernicus Hub, as well as Landsat imagery from the USGS. And what we're going to do is we're going to coordinate it with a time when we know we're getting a satellite imagery pass, preferably an optical image. And we're going to go out and see if we find any oil in areas that we typically do find or issue oil spill reports. And we're going to also collect samples if oil is found, as well as deploy the drone. So one of the other reasons why we can't just do it with the vessels that we have at the IMA is because typically we do find oil offshore, and it's not necessarily the best idea to take a drone like this out on a particularly small vessel. So we will be going out with the Coast Guard, who has larger vessels. So not only is it safer, but it's better for deployment of or the conducting of a drone survey. And once oil is found, we'll collect samples, we'll do fingerprinting, which will ascertain or help us to determine the type of oil. And that's particularly important because we do include thick oil sometimes if found from satellite imagery. So it will really help us to validate that. And under the Marine Space Remote Sensing Program, we do have the expansion of the oil spill as well as the validation activities. But we also have a couple of other components that are going to be launched very soon. So the Sargassum forecasting product will actually be launched in January, and the ocean health monitoring product will be launched later next year. It is one of the projects that is funded by our government through the Public Sector Investment Program, and is currently in its third year of funding allocation. And it really helps us to fulfill our role as a regional activity center for land-based sources of pollution. So the sargassum forecasting, I'm not sure how many of you are very aware, but the Caribbean in particular, we're being plagued by sargassum influxes. This year was one of the most long spread. We had one of the longest seasons for sargassum influxes this year, as well as we've also experienced sargassum washing up on shores that it's never washed up on before. So even for Tobago, usually it would have just kind of washed up along our Atlantic coast, but this year we did see more wrapping around into areas on the Caribbean side of the island where we previously would not have had much of a incident reporting of sargassum. So we did host a bit of a pilot mapping through some of the intense months this year. So between March to June, those are the months that we see most of the sargassum tending to come through. This year, we did see it up to August even. And it's really a combination of using, again, open source imagery like Sentinel-2 and Sentinel-3 ocean color products to map and identify the sargassum mats as they come across into our national waters, but using methods such as maximum likelihood analysis. So after we have the AO using that GIS to really try and predict where it's most likely to settle onshore, as well as through the use of a trajectory model, which will really be just be using surface currents. So we tend to use the same coastal behavioral units that we utilize now for things like coastal change detection because it's based on geomorphological characteristics for a number of different things because we realize, this is really one of the best ways to kind of manage our coastal areas. And so these are the areas that we'll really be using for our forecasting product as well as for Trinidad and Tobago. So as mentioned, we usually typically just get, sargassum on the eastern coast. But this year we saw in areas towards the southwest of Trinidad, even the northwest of Trinidad, as well as along our northern coast. So it's coming in so often and so dense now, the mats are some of the biggest that we've ever seen, that they're really just beaching up on all different shows now. And so we really will be utilizing when we launch the product and we host a sensitization seminar. We will be launching a citizen science program. So we will be installing signage on selected beaches across Trinidad and Tobago that will have a QR code for a citizen science form using Survey 123, but also to kind of capture. So we'll also have like a little shelf for you to put your phone and take a picture. And that will help us to really analyze not just the submissions for, the disease sargassum and how bad is it on our public beaches, but also to understand the variability of influxes throughout the year. So it's also going to help to inform further research. And understanding how sargassum and how oil interacts with our ocean currents, especially our surface currents, is particularly important for response managers. So when sargassum beaches on our shores, it is an issue for a number of different sectors. It affects our fisheries, it affects our tourism, it affects maritime and shipping. And it's because it can sometimes damage vessels and their machinery, but also when it beaches on shore, it starts to decompose, and there are negative health effects for human beings, for marine life from that decomposition of sargassum seaweed. And it really has posed a bit of a challenge for our regional corporations, so for the persons on the ground to clean up, to organize machinery and personnel to assist with cleaning up before the sargassum gets to the later stages of decomposition, which is really when it poses a particularly awful environmental and human health impact. And then the other component of the marine space remote sensing program is ocean health monitoring. So the development of a water quality product using satellite products. So using products like sea surface temperature, sea surface salinity, chlorophyll A. Sea surface salinity helps to act as a proxy for ocean acidification. And I think we can all recognize that we've been experiencing higher and higher rates of temperature change, as well as for long extended periods. So right now we are having one of the more intense periods of coral reef bleaching. We have been using a variety of products to help inform. One of them includes the Coral Reef Watch from NOAA, where they just started to use newly created categories for marine heat waves and coral reef bleaching. So before, their alert levels only used to go to 1 to 3, and now there's 4 and 5. And we have been on the fifth level of alert for quite some time. We are getting reports from public as well as from our own activities. When the coral reef ecologist team, when they go out and they do their dives, they're actually going next week again to host a public forum, and kind of not only share with the public and for the persons that live and interact with the coral reefs, um, but also for them to understand the implications of coral reef bleaching. So some of these programs are programs that are needed like now. Some of them are overdue. I think we could all recognize the impacts of climate change, and we all see a need for using, these freely available satellite products to help inform decision makers on the ground, to help inform ecosystem-based management and action for conservation, but also really just to bring to light what is the state of some of these ecosystems. So how resilient are these coral reefs to bleaching? And what really does that mean for a dive tour operator? What does it mean for someone who works in a hotel? What does it mean for fisher folk? You know, what does it mean for someone who regularly interacts with their marine backyard? And what does it mean for future generations, even? And then one of the ways we are hoping to communicate some of this information is through a report card. So through a very easily digestible graphic for like just basic ocean health. So just, a little less than ideal versus a little better than last time water quality. And I'm using those terms and not necessarily like a pass or fail grade, simply because that is really the kind of language that sometimes we have to use as scientists, with decision makers or with politicians. If you just say, um, it's a grade F versus a grade A, um, this month versus earlier this year, all of these things tend to really have quite a public uproar at times if not managed very well. And so, we will be looking at the best way to digest the remote sensing data and the Earth observations data, and, really compose it in a way that could be understood for a tier of different users and different applications, not just for ecosystem-based management, but even for public health management, for bathing beach water quality, and so on. Okay, so now we're going to move into the mangrove forest. So as mentioned, we have been focusing kind of heavily throughout this talk on ocean observations and the use of EO for it. But as I mentioned earlier, it's particularly important for us to understand how the impact on our land affects the oceans. And, not just through pollution, but also through conservation activities and rehabilitation activities. So mangroves have been recognized as a significant carbon sink, and in most instances, it is able to store and sequester at rates higher than that of terrestrial rainforest for the Caribbean. And so it's particularly important to understand the blue carbon that exists in mangroves, assess its capacity to store the carbon, sorry, but also, if these data sets are degraded, if these mangroves are cut down, if these mangroves are polluted and they aren't able to sustain the healthy conditions that they need to thrive, what does that then mean? And in some cases, it means carbon emissions, which is not necessarily helping our case towards mitigation and adaptation of climate change impacts. So these are some of the measurements that we would utilize to do that assessment of mangrove forests for above ground stores. They include a terrestrial laser scanner as seen in the right image of the screen. And this laser scanner helps us to do a number of things. As you can see on screen, our mangrove forests have very particular features. phenotypically, and that includes things like these massive prop roots that get into very intricate networks. Typically, the old way of measuring mangrove carbon did not include the prop roots. And it's particularly hard to actually take the time to go and measure them out by hand through physical mensuration. Um, but what we can do is use the terrestrial laser scanner to recreate the trees in 3D, which then accounts for the extra volume that would have been neglected by not including the prop roots. And that allows us the most precise assessment of the biomass of a tree. And therein, we're able to use allometric equations that's coupled with these physical measurements to understand the biomass. So these are some of the products that come out of the 3D laser scanning through using the terrestrial laser scanner. This is one of the point clouds that we would have collected. So, using that little laser scanner, so just using this guy over here and putting it at different points around one of the mangrove trees to recapture it in 3D, and then being able to extract a singular tree like this one on the right, to get a precise measurement for its volume, and then being able to use a carbon percentage either gathered through analysis from a wood core or through the species variable constant. And these are just other examples. So we would sometimes have to also put the scanner higher up on the tree and not just on the ground. Not just because of how insane the prop roots are, it's very intricate and sometimes pretty tall, but also to get a good characterization of the canopy. So the woody bits are the bits that store the carbon. And so if we only gather data from the ground, we're not going to be able to get that characterization of the branches in the canopy. And so we would have also coupled it, not just the physical measurements and not just the terrestrial laser scanner, but also airborne LiDAR. So having an understanding of the different canopy heights of the mangrove also help to understand and get an assessment for above ground carbon. So coupled with the tree heights and the carbon measurements and the plots of the forest, we would have measured thousands of trees. A number of plots would have been established in our mangrove forest across both islands. And the result of that is an equation that helps us to evaluate and really get a figure for above ground carbon. And so we would have gotten a figure of just over 1 million megagrams for above ground as well as below ground biomass. So that includes some of the root systems of the mangrove trees for Trinidad and Tobago, and this would have been based off of 2014 measurements because the aerial LiDAR was flown in 2014, and that is the most recent data set that we have for heights of mangrove trees. We would have collected some woody cores and they would have been sent to an elemental analyzer to give us a percentage of carbon that could have been used in the predictive equations. And then if you thought mangrove stored more than tropical rainforest, the soil below the mangrove stores even more. And so we would have done a preliminary assessment where we would have collected soil cores in partnership with the the forestry department in Guyana, their mangrove unit, as well as the university in Suriname, where each of these countries would have collected 10 mangrove soil cores, and we would have had a very preliminary and initial assessment of the carbon storage content in the mangrove soils. Right now, we are waiting for that report to be finalized, which is why I couldn't share the figure with you, but it is representative of the literature and in some cases more. And it really, really, reiterates that importance of recognizing mangroves through their ecosystem services and the important roles that they play for mitigation of climate change impacts through carbon storage and sequestration. And one of the projects that this has helped to inform is a new project that is now starting, and that is really assessing not just carbon storage, which is what we would have all been doing before, but also sequestration. So it is getting into more of the scientific particulars of blue carbon as it relates to things like eddy covariance and carbon flux management, balance and management through the cycles of mangrove forests. And this is really going to help Trinidad and Tobago to have an understanding of how we can participate in carbon markets. So that's even further assisting with our conversation and our argument towards conserving our mangroves. If we're able to then show that it has this economic value or even this ability to provide some kind of revenue, it really helps our country to be able to conserve our mangrove forests. Because unfortunately, in the Caribbean, we do have a history of going towards coastal development and not necessarily co-designed coastal development or sustainable or ecologically, framed coastal development. And so unfortunately, across the islands, we have lost mangroves to coastal development, but we have since recognized the utility and the merit of conserving these valuable ecosystems. And so, you know, work towards blue carbon management is really helping to sustain those efforts. And yeah, so I'm going to stop there. I do have on screen a QR code that gives you a better view at the EO value chain case study for ocean observations, as well as the folks that would have developed and, you know, really worked towards the communication and, I guess just the public education campaign towards using Earth observations for ocean observations. And yeah, I think Virginia, you can open the floor now if you'd like to for questions.
Of course. Thank you so much for that wonderful